In this video, we'll look a little bit more at infinite limits. Okay, so the graphical kind of stuff that we've run into is, what do you do if you have a function which has a vertical asymptote? So the function might look like this, for example. And so what do we how do we talk about the limits near these asymptotes? So for this one, we would say, so if this red function is the function f, we'd say that the limit as x approached, and let's call that number here a, wherever the asymptote is, we'd say that this one does not exist. And the reason is that, just like in the last set of stuff, the left and the right-hand limits are different. So this one, the left-hand limit, oops, x goes to a, from the left, we're going up, so we should guess that this one is plus infinity. Whereas on the other side, approaching a from the right, the y values are crashing down towards minus infinity. And so again, these two answers are different, and hence the overall answer does not exist. Okay. Now, so this is sort of a graphical approach to it, but how could we sort of make this same argument without actually looking at a graph? So let's take a simple function here. Let's say that we have f of x is 1 over x minus 1, and we're going to consider the limit as x goes to 1 of this function. Okay, so the first thing to note is that because we're approaching 1, and 1 is a problem for this particular function, we can't just plug 1 in and be done with the problem. If we were approaching 7 and this was still x minus 1, you could just plug in 7, no problem. But unfortunately, we don't have that here. So in order to figure out what this is, we first need to figure out, just like before, the left and the right-handed limits separately. Okay, so let's consider x goes to 1 from the left of 1 over x minus 1. Okay, so that's what we want to compute here. Now, the way that we can kind of think about this is first to say, we can't just plug in 1. It'd be nice if we could, but we can't. Can we do anything to simplify this fraction so that we could plug in 1? And unfortunately here, no. This fraction is already in lowest terms. So there's nothing we can do to simplify. Okay, so we kind of have to reason through it in the following manner. If we approach 1 from the left, what we should be thinking, okay, so think x approaches 1 from the left means that x is less than 1. So something less than 1, if I then subtract 1 from it, I'm going to have a negative number. Okay, so, and I'm going to put this in quotes, this thing is of the form 1 over a negative tiny number. Okay, so now we know if you divide by tiny numbers, you get really, really big numbers. And then the fact that there's a negative here means that you'll get really, really negative numbers. Okay, so in my mind, what I'm kind of thinking is, all right, what about if I have x is 1.1? If I take 1 away from that, or sorry, I'm coming from the left in mind. So let's say x is 0.9. If I take 1 away from that, I have a small negative number, 0.1, negative. And if I divide by that, then I'm going to get a really, really negative number, namely negative 10. That's pretty big. And if I were to make this x a lot closer to 1, like 0.9999999, subtract 1, and I still have a negative number, but it's ridiculously tiny. And 1 over tiny numbers are ridiculously big with a negative out front, makes it ridiculously negative. So from that sort of argument, we should expect that this is minus infinity. Okay, and on the flip side, if we come at it from the right, well, now I'm going to be thinking if x approaches 1 from the right, then that means that x is actually bigger than 1. So I'm going to think in my mind numbers that are bigger than 1 but pretty close to it, like 1.1 and so on. Okay, so if I subtract 1, I now have a positive tiny number. And so we'll put this in scare quotes too. So I have something over a positive tiny number, and by the same argument as before, we'll have an infinity, but this time it'll be plus. Okay? All right, so now it's unfortunate that these two answers came out different, and so what we would be forced to conclude is that this answer does not exist because the left and the right-hand answers were different. Okay, so from this we can kind of figure out what an infinite limit should look like both from a graphical standpoint and then also from a numerical standpoint by kind of thinking through in our head how this goes. So the problems on the for the pre-class will be pretty similar, different numbers, different functions a little bit, but you should have no trouble.